So the where?
Okay. Which one are we looking at? Page what?
Number 3, page 1.
Page 56?
Yeah.
$56, okay, which one?
3.
3, okay. Let's have a look, see. Now, can you see okay?
Yeah.
You sure? So, what you have here is a town that consumes 12 units of energy and then a year later consumes 13 units of energy. Write down the exponential formula for this. So, the energy will equal A, E, B, T. Is that okay so far? Because I tell you it's exponential. So that's what. Our job now is to find the A and the B. Okay. So we can use the fact that when T is 0, what's E?
12.
Good. And when T is 1?
15.
So if I sub that in, I got 12 equals AE0, so A is 12. I have E equals 12EBT. Now actually, do you know what? I'll use days. 306. Will I use days or will I use years? What do I say in the question? Hey! You made it. I'll use days. So that'll be 365.
I'm going to use diesel.
I didn't say in the question, so it doesn't matter. They should say it in the exam. Huh?
We used to get the same answer.
Oh yeah, same answer. Yeah. So we can sub this in next. Hey?
It's actually here.
Yeah. Last tutorial before the exam.
Yeah.
Can I join in the class?
Yes. All.
There was cake?
Yeah, welcome.
Can I grab my math book?
Yes.
Is the
Thank
slide
you.
addicting?
Thank you. So you got the cake. Matar got the cake. Nice.
Have one.
So it was my idea.
Oh,
My
what's
idea.
your good?
It was
We're waiting for Priscilla?
Yeah, no, Sabrina.
Sabrina? Okay. We're looking at page 56, if you can open that. Yeah. 56.
On your book. Where is your bag?
Guys, you got your book? 56. Yeah. So, as I was saying, well, you're asking, should we use days or years? It wouldn't actually matter. We're doing question 3 on page 56. Okay. So you put this value in. 13 equals 12E365B. So that means 13 over 12 equals E365B. This is question 3 on page 56. Now what do we need next to get the B? Yeah. Yeah. Log 13 over 12 equals 365B. So then you divide. So have you got your calculator? ln 13 over 12 over 365. So I hope,
2.19.
yeah, with 10 to the minus 4, is it?
Yeah.
Like this.
Yeah.
Okay, so that's the first part of the question done. You have the exponential formula. Energy is equal to 12e 0.000219. Time, energy increases like that. Okay. For the next part of the question, they say, what if instead you imagine that the relationship is a straight line? So what would be the formula if it was a straight line? It would be E equals something like mx plus c, right? Yeah. So let me just use mx plus, mt plus c.
Why using C?
Huh? Oh, because t is on the x-axis. It's time. Yeah? Yeah? Now, remember that this point here is 12, and this one here, 365 days later, that is 13. So what should I get first? What's the easiest thing to get in this formula? You can actually see one of the letters already. C is 12, isn't it? And then how do I get the m? Yeah? How do I get the m?
Sub in.
Oh, come on, Mikey Wakey. How do I get the m?
Is B equals to 0?
What?
No.
Ah, come on.
M is equals to.
Oh, gradients. 13 over 12 and then 0 over 360.
13 minus 12 over.
360 minus 0.
Yeah.
God.
So that's 1 over 365.
Bro, like,
Yeah.
it took us forever.
What am I
I'm trying it as 2.74 times.
Like that. Okay. So what we've done is we've worked out a formula for the energy, like this. And we've worked out a formula for the energy, like this. And the last part of the question is, if you use these formulas to predict the energy 2 years into the future, will they give the same answer? No, they'll be different, and I want to know how different. So using your calculator, I want you to sub in here for t. I did say 2 years, isn't it? Yeah, 2014. So put in for t 365 times 2, and in here 365 times 2.
I have another question.
Oh, well, let's just finish this one first. Yeah.
You know, related to this.
Yeah.
You did on the graph A over T, like T on the X and A on the Y.
Yeah.
Like, why is it not T on the Y and A on the X?
Oh, if only Colin was here. This drives him crazy with biology students. Like, you never put time on the y-axis. Never. Never. And he would say in the biology exam, he would see students making a graph, and you put time on the y-axis. Time never goes on the y-axis. It always goes on the x-axis.
Okay, but if it was like a question that wasn't related to time, will it still be like, how do you know which one to put on the axis?
Yes, temperature and time. Never time and temperature. Usually it's the context. So the x is the thing that moves forward, and the y is the thing that you see change. So like in this case with the town population grows, and then over time, and then you see a change in its energy use. So it's kind of also to do with ordering, you know, the thing that happens first that causes an effect in the other thing, that's the x and then the y, you know. So yeah, it's kind of like an ordering thing, which is affecting which. So if you put it so that the x affects the y. Yeah, that's why you never put time on the y-axis, because your temperature never affects how much time passes. Time always passes. Do you know? Okay. Did you pop those two in?
1.487. Okay, use yours.
Oh no, it can't be that. It has to be more than 13.
14.
Oh,
Yeah.
there's an E. Never mind. I forgot the
Yes.
E.
14.08.
And then the other one?
14.0002. 3 zeros next week.
They're 14.0.
Ah,
Okay. Okay, so the difference between the two is 0.8. Now, my next question I'm going to ask you is the type of question you get in the exam for 1 mark, a sort of follow-up question at the end of the question. And the question would be, which formula is more realistic for time and energy? That the energy grows like this, or that it goes like this? Which is more realistic?
Second one.
Why is that? You have to give a reason.
Because as
As the time.
Yeah, well, let's see, since she said the second one, let's see what she says. Yeah?
I think because as the time increase, the energy increase.
But that's true for the first one too.
No, that's what's stable.
Oh, okay, my picture is bad. Let me try it again. I understand what you're saying now. I'll try and draw nicer. Right, so I want you to kind of see that it is always increasing. It's not flat here, it's heading upwards. And here it's the same as well.
This is like slope.
There is a slope, yes. I know it looks flat because my picture's terrible, but it's going up. There's a bit better. It's going up. Which would you say now? Well, I really want to know what your reason is, really, for whatever one you pick. Now, second, yeah. What's the reason? Yeah.
Because I think at the beginning it was.
I think energy has to be resolved and to not be.
Oh,
It doesn't be exponential.
oh, we're not getting good answers.
No,
it's
but
the
this
first
is
one.
second.
It's the first one. I feel it's the first one.
As time goes on, the population increases exponentially. So that means more energy will be used exponentially. So like 2, 4, 8.
Correct.
Instead of 1, 2, 3.
See an answer thief. Yeah.
Just because that stereos doesn't
The person who said the joke, the person who said it loud.
Oh.
The first one.
Why?
The first one. And the reason has to come from something you will learn in biology, that when you're looking at growths of systems, they usually at the early stage grow exponentially. The other students told me you did this graph with column, the enzyme graph.
Yeah.
It grows exponentially,
Yeah.
then it's linear, and then it stabilizes.
Yeah.
So it's exponential at the beginning, and then linear, and then
Why
constant.
here is perfect? Is there-
I don't know, yeah. Yeah, much better here. So it's exponential. It's the better fit. However, another question could be, why in the long run is it wrong to use the exponential? So,
Because there will be limiting factors that will
limiting factors, yeah. So in real life, even if you use exponential, it won't continue exponentially, will it?
No.
It has a limiting factor. Is that a biology term as well?
Yeah.
Yeah, limiting factor. Well, it can transfer into this. It works. Yeah. Yeah. What did this? Was this an enzyme?
Yeah, it was.
And what was on the x-axis? Temperature? Temperature?
Substrate is a limiting factor for enzyme.
No.
It was
temperature
concentration
and the
of-
Y.
Temperature here?
Yeah, and in the
What?
X.
No, it wasn't temperature.
Temperature's in.
It was velocity.
No, I'm sure.
He literally told me velocity.
It was velocity and concentration of substrates.
No, I'm sure. Where is that side?
You guys all study biology, don't you?
Yeah,
Yeah.
Technically.
He
Which-
literally told me velocity.
Nikita, do you remember which way around it was?
I told you, I think I'm sure again.
That's not the
You
same
hear
graph.
it?
Substrate concentration,
That's not
it
the
will be
same
one of
graph.
the
That's not the same graph.
This one?
measures and
No,
is
that's the-
limiting
I'm
factor
talking
because
about this
enzymes
one.
need
Let me see the
like
graph.
if
Turn
you
it back, turn it
have a
back.
substrate.
That's the one.
So-
If we will add
So-
substrate and all enzymes are busy, it will not work. That's why it's limiting.
So concentration and
This is
what,
concentration.
temperature?
Temperature.
Yeah,
It's not temperature. It's concentration of
or
salt
time.
and
Like
temperature. The one that it
oh,
goes
it's
like
a bit
this.
This one.
varies. Time to
Yeah. We'll see.
That's down, substitution, wasn't here.
The law sets it. Thank you.
What?
As we said, velocity is,
I was
Velocity.
thinking about.
As he said.
velocity is on the Y, because he said that in class. Usually told me.
Velocity here and on the
I was
X,
talking about
Substrate
temperature.
concentration.
concentration.
Yeah.
Oh, the temperature I have absolutely no idea.
I think there is a graph you do with column that has temperature in it, and it does have something to do with activity. Is it a protein or?
Yeah, we did this.
That's
How
the
did-
thing, but I can't remember.
Yeah, guys, I just remember from last year.
Yeah.
Turn it back.
Time taken is this one, temperature here.
Yeah.
Why
I
don't
just
other
temperature is always
teachers
like.
record
It's
their
just
lessons?
down.
Huh?
Yes.
Why?
I know temperature is always
other
on the
teachers
X.
Last time
record their lessons?
Why?
I don't
Because
know.
temperature just.
You can suggest it to them.
Temperature never gets
You
over.
should suggest it to them.
I should.
Never.
Well, who's the class rep?
Y-axis.
Are you the class rep?
No.
Well, you can talk to him afterwards as a suggestion.
This one in the corner.
This fella. This guy
Yeah.
in the corner, huh? All right. Right, next now. What question do we need to see next?
Yeah, I have to do.
Yeah, which one?
24,
Page 24, yeah.
5 and 6.
5 and 6. So, don't worry about number 6. It's not going to be on your exam, and it's not going to be on your final exam. So, I can do 5 and 6, but it might just be better just to do 5.
Okay.
Will I just do the first one?
Yeah.
Yeah, okay. Now you'll need your calculators here. So I tell you on page 24, 5a, 3x plus 4 and 2x minus 3 are factors of bx cubed plus 7x squared minus 15x plus q. So what's the remainder if they're factors? Who remembers that? No, yeah, but what's the remainder?
Zero.
0 if they're factors.
Yeah.
There's no remainder. And how do you calculate the remainder? Ah, yes, but what's the easy way to calculate the remainder?
You put six inside.
Put inside.
Substitute.
Yeah.
You substitute minus 4 over 3 and 3 over 2. Yeah? What's the name of this rule? Excuse me,
English.
Alex. I need you listening, not talking, please. What is the name of this rule?
Remainder.
Yeah.
What's it called?
Remainder.
Remainder what? Theorem, yes. Remainder theorem. So you put these two values in. Minus 4 over 3 cubed p. David.
Plus a week.
Maybe he's just jealous of you.
What?
That escalated so fast.
Maybe. Let's see. Right. Minus 15 times minus 4 over 3 plus q equals 0. And then you do the same thing for the 3 over 2. So you get 3 over 2 cubed p plus, yeah, good.
3 over 2 squared minus 15. 3 over 2. Plus Q.
Yeah.
So this one.
And then you solve them together.
Mhm.
Now, you'll need your calculator to clean this up, but do you know what to do next? Shh.
Sorry.
I'm asking her a question. Do you know what to do next? What would you do
Minus,
next? Good, yes. You would minus the two of them. And what would that cancel?
Q.
Q, yeah. And so you can solve for P.
Mhm.
And then once you have P, what do you do?
I substitute.
That's it, yeah, and then you get the Q. So what was the problem here? Because I think you know how to do this one.
You were just like confused.
but now that you see how to start it, it's
Yeah.
probably okay. Yeah. I think this one's okay for you. Yeah.
Instead of minusing, instead of minusing them, can you just equate them to each other?
These two?
Yeah.
Yes.
These are multiples.
You can do that. Yeah.
Sure.
Right, what else do we need to see?
Page 72, number 5A.
Oh yeah, okay. I did that with the other group as well. That confused them. You'll be disappointed by it.
Is it just like divide by E?
Not quite, but
No, I know.
yeah? Okay. Well, let's see when we get to it if you know what to do. So, I want to find out where these two meet. So, yeah. So, what method should we use here? What method? Yeah, but what method? Yeah. So, what do I say next? See, guys, come on. You say you know what to do. So, tell us. You checked.
Yeah.
All right, fine.
Divide by.
Okay. What do we do next then?
EX
EX equals E minus X, yeah. E power minus X.
Then
Yeah?
log
No, stop.
Why
Stop.
y?
Question, yeah?
Why equal e to the power x?
No, I'm giving you this in the question. Sorry, this is page 52, 5A.
Oh, 5a.
Yeah. So, what's happening here? We made the two equal, right? What's next?
log
No?
Divide.
No?
Time negative 1?
No.
Why not log?
I don't need to. You don't need to.
you cancel
Well,
that.
and
Just
so-
say X equals minus X.
So it's nothing.
Yeah, something like that. Right. Continuing, what's next?
divide negative 1.
Nah, let's do something else.
Reject all the x to the other side.
Yeah, so what do we have on the left?
0.
2x equals 0.
And x equals 0.
Yeah. And y will equal 1.
Yeah.
Yeah. Yeah, I know.
Tricky question for like people that.
People like
Yeah.
me. Oh my god.
Yeah, I know. That's it.
Oh
I know.
I have another question.
Yeah, which one?
Page 20,
Yeah.
2a.
Sure. Page 20, question 2a. How many roots does this equation have? Minus kx squared minus 4kx minus 4k. And k is not 0. Yeah? What's wrong, guys?
Everything right?
Are you sure?
Yeah.
Okay. Right. How do we get the number of roots here? What's that called? Yeah. But what's the formula called here?
B squared.
Yeah, what's the name of that formula?
Quadratic.
This guy has a name. Discriminant.
Oh,
Yeah. So what's the b squared here?
4, negative 4.
K.
K.
Squared minus 4. What's the a?
Negative k.
Good. And the c?
Negative 4.
Now, what's minus 4k squared? 16k
K.
squared. Minus minus minus?
Plus.
Plus.
No, minus.
Still minus.
Still
Sorry, minus. My goodness, minus, yeah. And what do I get here?
4k.
16. 4 by 4 is 16. And k by k?
K squared.
K squared. Which equals, what's wrong? That's right, isn't it? Yeah, which equals 0. So therefore, how many roots? One root.
Because it's equal to 0.
Maybe you question.
Yanni?
What about question 3?
Yes, let's do 3. Can I do 3A? Look at 3A on the same page. Can I scroll down? Yep. 3A. So, I tell you that, well, I won't write it out. if you look at it, I tell you it has one root. So what do you know about the discriminant?
So it's equal to 0.
Yeah, and in this one, maybe you can read it out for us. What's the b squared minus 4ac? So what's b squared?
2k minus 2.
Yeah, minus 4. What's the a?
Negative x plus 4.
Minus k plus 4, and the c?
Negative k minus 1.
Yeah, and this should equal 0. So let's solve this. 4k squared minus 8k plus 4 minus 4, and let's multiply these two together. That's plus k squared. What the heck is that one? That's plus k minus 4k. That's minus 3k minus 4 equals 0. 4k squared minus 4k squared? 0. Minus 8k. Okay, now just be careful. Minus 4 times minus 3? 12k minus 8k? 4k. Now, minus 4 times minus 4? 16 plus 4? 20. So k will equal minus 20 over 4, minus 5. Okay.
Can we use page 48, number 4? 8. I don't know what to do.
The answer's wrong for that one.
Which one?
4a.
Yeah?
Yeah.
Page what?
The answer's wrong.
How is it wrong? Like, I don't even know how to do it.
41, what question?
For the 48.
The person sitting beside you will show you her answer because she's the one who told me it was wrong and I checked. Remember this one? Yeah? You seem shocked. Do you remember?
It's negative.
But how to get that form?
Let's have a look at it. Let's have a look at it. But I know one of the answers is wrong there, but let's have a look. What part was wrong? I forget.
B.
The B one was wrong, was it? Was it? Okay, anyways, let's have a look. So, page 48.4. I wanted you to simplify 1 plus x squared over x, isn't it?
Yeah.
Right, let's expand on the top. What do I get?
It's 1 plus x, yeah? So
It's
hx.
1 plus
Yes. Yes. 1 plus... Come on.
2. Wait, 1 plus x
2x.
squared plus 2x.
No,
Yeah,
two
or
x.
1 plus 2x plus x squared. Over
X.
x. 1 over x
Oh my
Plus-
gosh, that's simple. Okay, never mind.
2x over x plus x squared over x.
So just change it to x.
Yeah, well what power is this? X power.
Negative 1
Negative 1.
And what power is this?
2x.
to
Zero.
x.
0, good. And what power is this?
1.
1.
Good.
Oh, is that all? So like, what's the point of ABC?
That's 1.
What do you mean, what's the... Oh yeah, so 1, 2, 1. So I said to write it in that form.
Oh.
Yeah?
Okay.
So ABC is 1, 2, 1 and small abc is minus 1, 0, 1.
Okay.
Yeah. Okay.
I have another question.
Which one?
Yeah, 18, page 18.
18. Yeah?
4.
Oh, no. Forget about that. That's not on the exam. And it's not on the final exam. That's just a Stephen tricky question.
Huh.
A bonus question.
Will you send us kind of similar questions to the exam ones?
I made the exam this morning. And it's tough. I'll give you some pointers for the exam, okay? So I made the exam have 3 parts, question 1, 2, 3, but each question has multiple parts, okay? So question 1 on the exam is algebra topics, an algebra question. You know your algebra topics like quadratics and cubics and simultaneous, all that type of stuff, okay? Question 2 is exponential and log question. And then question 3 is sequence and series question. That's how I'm breaking it up, isn't it? So like, that kind of, let me just see.
Which one is the second one? Geometry?
Exponential and log.
Exponential and log.
Yeah, so basically I made question 1 algebra, question 2 exponential and log, and question 3 sequence and series. which covers the 3 chapters we've done. Now, I think you'll find question 1 is easy. It's just straightforward algebra stuff. The exponential and log question isn't too difficult. It's a practical problem. It's the usual type of things we've been doing in class about finding the constants and making predictions. You know, standard enough.
How much time did you spend to praise the exam?
Not much. Because I stole the questions from somewhere, so not much time. Copy, paste, copy, paste, copy, paste. There, finished.
The reason I was asking is like, is it possible for you to do it again, but like different one, but similar to the example? So we could.
I don't know if that's possible. I'll give you some, guys, look up. I'll give you some pointers, okay? So the first question on the exam is algebra. And in my opinion, that's an easy question. You know, they're very standard algebra questions. I can't remember what I said, but it'd be things like, you know, complete the square or solve the simultaneous equations. You know, the usual stuff. Question 2 gets a little bit harder.
Was it a question or a section?
It has like parts A, B, C, D, but it's one question. But it has like multi-parts, like A. So I think question 1 has 4 parts, A, B, C, D. No, that'd be too nice for you. Yeah, too nice. Exponential and log is next. Now this is a practical problem question, but it's just like what we've been doing in class. You know the way where you have to calculate the A and the B and make a prediction, and I think the question also includes, like, I give you 2 different formulas or something. You know, very similar to what we're doing in class. The last one, so I would call this a medium difficulty. Now the last one is sequence and series, and I'll be honest with you, that's a hard question. How's it hard? Oh, you'll see when you come back after the break. It's hard because you just have to read carefully and just think. You can't just jump. You can't just jump straight in. Kind of, maybe not. Not so easy to describe. It's interesting. Interesting. That's what it is. So this is what I think. Guys, please. I haven't decided on how to allocate the marks. So I was kind of thinking that, you know, I might do something like as an example, I could make this one 40 marks, for example. I could make this one 30 and this one 30, for example. Because this one's the easy one. It has the basic stuff in it. If you can pass this question, then you've passed the exam. And then this next 30 is to try and, you know, see the different levels. And this last one I said is quite hard. And the reason for this is to make sure that if you get more than 70 in the exam, or even more than 80, then you're telling me that you're a very capable student. So I think I will make the marks 40, 30, 30. And that's good, because the one with the most marks is the easiest one, okay? But like I said, it's not all easy. These last 30 marks are quite hard, okay? But I think everybody will find 1 and 2 straightforward, because they're just like what we've been doing in class, okay? Don't freak out when you see number 3. It's only there to really see who is top at the top. Yeah?
If you're able to solve all the homework you gave us, so will, as a person, have problems with the 3rd one?
If you can do everything in this workbook, you will ace question 1 and 2. But only those with true brilliance can ace number 3.
Is it a tricky one?
It's hard to describe. You'll see it when you do it. It has tricky parts to it.
Well, it's like, it's all about maths. Like,
It's all maths?
Like, straightforward. You don't need to, like,
I'm not asking you to prove anything. It's all straightforward. Yeah.
is it practical problem?
It's a type of practical problem.
Is it a lot of words in the
Yes.
question?
Yes.
Can I do one more question?
What one?
56.4.
56.4. Yes, we'll finish off by doing 56, number 4.
Okay, that's good.
Yeah. Page 56, question 4. Anne invests at 12% APR converted monthly. This means she gets 1% per month. How long until she doubles her money? Okay, so let's start off by saying she... Guys, you looking? Come on. You looking? So we start off by saying at the very beginning she has A. That's how much money she has. We don't know how much. We'll just say A. Okay. Then after 1 month, how much more does she have? 1% more.
101.
Well, that's if she starts at 100. We don't know actually how much she starts with.
Oh.
So what would I multiply A by?
1%.
Yeah, so
So, 1.0.
Yeah, 1.2.
1.01. And then after another month, what happens? Multiply by 1.01 again. And after another month, multiply by 1.01 again. So if she keeps her money with the bank for X months, yeah?
Equal to that one.
Oh my goodness. Okay, I'll say it again.
Question.
David, I'll say it again, but you need to be listening.
Okay.
Okay, alright, first are you looking at the right page and question? That's not convincing, but okay. Right, so we start off by saying she puts a amount of money in the bank. Right? And then after 1 month it increases by 1%. Yes? So how do you increase the number by 1%? Yes. See, I don't know.
Multiply by 1%.
You multiply it by 1.01. Hey, he doesn't understand. Explain it to him. Why do you multiply by 1.01?
Because
Listen to the guy dressed like a clown. Why do you... He's going to explain something to you. Go on.
because you already have 100 and we increase by 1% every. Is it every month?
Every month?
Yeah. So we increase 1%
So it's
every
first
month.
month, yeah.
Yeah.
So if you put in the calculator, you multiply by 1.01. So the 0.01 is actually 1%.
Good. Good. He's exactly right. The 0.01 is the 1%. So by multiplying by 1.01, you've added on 1%.
Okay.
So it's basically 101 over 100.
Yeah, 101 over 100, yeah.
That's all I just needed to do.
I have another
Okay.
question.
Okay.
There's no time.
I'm gonna try now.
تخرع أطلع.
I got it.
Continuing. So after another month, we multiply by 1.01 again. So after X months, what happens here?
X.
Yeah, where's the X go?
1.01.
Guys, come on. This isn't difficult. It's the last question. Just think about it. Listen to me. After 2 months, we multiply by 1.01 and 1.01. After 3 months, it gets multiplied 3 times. After X months,
Multiply by X.
well, where do I put the X? Power.
Yeah.
And we want to know... Yeah, look at what I'm working with. Right, we want to know how long until she doubles her money. So if she starts with A, we want to know when will this equal? 2A. And what can I cancel on the left and the right? So I'm left with this. And how do I find X? Log
Log
base...
2.
No,
1.01
Yeah.
over 2.
which will equal 70.
Interesting.
Very interesting, I think.
This seems like when everyone is drunk and he's still sober.
I have another question.
Well, I'm not sure if there's time though. Which one is it?
26.
Yeah. Which one? Which one?
T.
2.
3. Go to 26.
Okay. So we don't have time to do this, but I would say not to worry because I'm not giving you this sketching question in the exam.
Oh, there is no sketching?
I didn't say that. I said I'm not giving you this sketching question in the exam.
Could be worse, sir.
It could be worse, or
Worse.
could be better.
Plus plus.
I'm not going to ask you to sketch a cubic. But that's not the same thing as saying I'm not asking you not to sketch.
But
What could I ask? Linear, quadratic, exponential? Who knows, but not cubic.
Please be the simplest one.
Alright, look, we'll leave it there. We'll leave it there.
Can I just say,